In this video, we're going to talk about the proofs of the sine and difference formulas for sine and cosine. We're going to start with a unit circle, and we have an angle inscribed. Actually, we have two. So what I want to point out is that our angle alpha actually lives here. So if it was in standard position, it has a terminal side here, and then we have the x-axis as the other side. Our other angle here is going to be beta. So beta is just from our x-axis up to this as its terminal side, which allows us to have cosine alpha, sine alpha, and cosine beta, sine beta as the points for the two that are indicated. Now what we do need is to talk about this. That I'm going to call D, and that's really important. That's our distance. Because we're talking about the unit circle, we know that the length of each of these radii is just 1. Now let's suppose that we took this angle, which this was our first drawing here, and now we rotated it. So essentially I brought this point down so that it corresponds with 1, 0, and then I moved this point around the same amount so that these lengths are preserved. So now what I have is the measure of just this part here. And that actually is alpha minus beta. So it's the measure of that part of the angle that is past beta on the unit circle. That means that the name of this point would now be cosine of alpha minus beta and sine of alpha minus beta. So let's talk about what the length is then of D here. So it's going to be the square root of cosine alpha minus cosine beta squared plus sine alpha minus sine beta squared. And that's using the distance formula because really D is the length between these 2 points. Now let's look at this distance here for D. And we're going to use the same thing. We're going to use our distance formula. And so what we have now is the cosine of alpha minus beta minus 1 squared plus the sine of alpha minus beta minus 0 squared. But wait, there's more. Remember that this angle here and this angle here that I colored in green, those are the same angle, which means that these two distances are equal to one another. And that is what allows us to set up the proof for our sum and difference formulas. So on this screen I have the same one that we had before, but I've now actually added in here what these guys are. So what's interesting is that I mentioned that the lengths are the same, but that means that the square of the lengths are the same, which means that cosine of alpha minus cosine of beta squared plus the sine of alpha minus the sine of beta squared is going to equal the cosine of alpha minus beta minus 1 squared along with sine squared of alpha minus beta. Now I went ahead and left off the 0 there because, well, alpha minus beta minus 0 is just the sine of alpha minus beta. And when we square it, remember the square goes by the sine. So what I'm actually going to do is expand this and this and this. And I'm going to go ahead and just write it out without you having the video going so that it doesn't take forever. But please, if you have questions or you get confused, please make sure to post this on the discussion board. So at this point, I have expanded both this one and this one. And I get cosine squared alpha minus 2 cosine alpha times cosine beta plus cosine squared beta plus sine squared alpha minus 2 times sine alpha sine beta plus sine squared beta. Expanding the right side is a little more clear. We get cosine squared of alpha minus beta minus 2 cosine alpha minus beta. And that would be multiplied by 1 from here, which is why there's not a second term with it, plus 1. And then again, our sine squared alpha minus beta comes down. It's important that we remember our Pythagorean identities. So remember that cosine squared theta plus sine squared theta is going to equal 1. So I'm going to rearrange some of these terms using the commutative property of addition, and I'll show you how we group them to get some 1s by using the Pythagorean identity. This gets a little long, so I'm going to explain. I've grouped cosine squared alpha plus sine squared alpha together. That's going to give us 1. I've grouped cosine squared beta plus sine squared beta together. That's going to give us 1. These two terms here didn't change. And on the right side, I've grouped together cosine squared alpha minus beta plus sine squared alpha minus beta, which is going to give us 1. And then these guys didn't change. I just had to write them a little funny because I ran out of room. So using a little bit of algebra, we have 2 minus 2 cosine alpha cosine beta plus 2 sine alpha sine beta. And again, I just factored the negative 2 out of both of these guys. And that's going to equal 2 minus 2 cosine alpha minus beta. If we subtract 2 from both sides, we then have negative 2 times cosine alpha cosine beta plus sine alpha sine beta is equal to negative 2 cosine alpha minus beta. Dividing everything by negative 2, we're left with the statement that cosine alpha times cosine beta plus sine alpha times sine beta will equal cosine of alpha minus beta. I'm going to use what we just found in order to derive the other equations for this. So what if we replace beta with negative beta? So now we have cosine of alpha minus negative beta, which will be the cosine of alpha plus beta. But let's see what happens to the rest of the expression when we do this. So we're left with cosine alpha cosine negative beta plus sine alpha sine negative beta. So we need to go back to our even and odd identities. Remember that the cosine of negative x is the same as the cosine of x because we have that symmetry on the unit circle with regards to the x-axis here and here. But when we talk about the sine of negative x, we don't have that same symmetry because we're talking about here and here, and we actually get the opposite of sine x. So let's fill that back in up here. We get that cosine of alpha times the cosine of beta plus the sine of alpha times the negative sine of beta. And we end up with cosine alpha cosine beta minus sine alpha times sine beta. And again, this is equal to cosine of alpha plus beta. So you'll notice that this SIGN and that SIGN are opposites. In order to show the relationships with sine, we need to remember that, and I know you guys talked about this in class, the cosine and sine graphs are really just a shift of one another by pi over 2. And we're going to leverage that because now we're going to replace alpha with pi over 2 minus alpha. So I've already written this out, including our pi over 2 minus alpha, but things we need to remember. We need to remember that the sine of pi over 2 minus alpha is going to be cosine alpha. We need to remember that the cosine of pi over 2 minus alpha is going to be sine alpha, which means if we take the cosine of pi over 2 minus alpha minus beta, so look at what I did. I actually factored out a -1 in here. In order to change everything, I factored out a -1. So make sure you take note of what I did there. But that's actually going to then equal the sine of alpha minus beta. So if we go back up to this statement, we see that the sine of alpha minus beta is equal to the sine of alpha times the cosine of beta minus the cosine of alpha times the sine of beta. Finally, we're going to work on the last of the cosine and sine sum of difference formulas, and it's the same as we did in the beginning. We now have the sine of alpha minus beta, but we need to replace b with negative beta, so we get the sine of alpha minus negative beta is equal to the sine of alpha times the cosine of negative beta minus the cosine of alpha times the sine of negative beta. This simplifies then to the sine of alpha plus beta. Remember that the cosine of negative beta is just the cosine of beta, so this first statement actually does not carry a negative sign. But also remember that the sine of negative beta we can replace with negative sine beta. So that is going to switch our sign in the middle to a plus. And again, we have cosine alpha, sine beta. So this is what you've all been waiting for. We have proven the first 4 of these. You do just need to know them. You'll never be asked to prove them, but I feel like if you know where they come from, they seem less esoteric and you can be more connected to them. You can also derive, if you want, the tangent sum and difference formulas. They are here and they do come from, you just need a little bit of algebra to apply in order to get them.